All right, so this is 5.3 day 3, which is solving trigonometric equations, but this is with a calculator. Okay, so this first part here says consider the equation cosine of theta equals 0.6 on the interval 0 to 2 pi. How many solutions are there? I don't care what the solutions are at the second, but how many are there? So I say, okay, I have 4 quadrants. All students take calculus. And cosine's positive in the first quadrant and in the fourth. So there are 2 solutions to this. Okay, so let's keep that in mind. There are 2 solutions to this equation. Okay, so now I don't know the angle that has a cosine of 0.6, right? I don't know that off the top of my head because it's not one that I have memorized from the unit circle. So we're going to have to use our calculator to help us solve this. So if we use cosine inverse to solve it, because that'll help us find the angle, your calculator is only going to give you one solution because cosine inverse is only defined in quadrants 1 and 2. I feel like that sentence doesn't make sense. Let me read it again. Because cosine inverse is only defined in, cosine inverse is only defined in 2 quadrants, quadrant 1 and 2, right? So cosine inverse is only defined in these 2 quadrants, right? And since it's positive, it's only going to give us the answer in the first quadrant. So you need to think about the unit circle and where cosine is positive so you can find all the angles that satisfy the given equation. So basically, we have to use the unit circle to help us get the second answer, okay? Okay, so first off, let's see how our calculator is going to help us. So we're going to do cosine inverse of 0.6. First off, we have to make sure our calculator is in radians because this is in radians. So I'm going to go to mode, make sure it's radians. It is, so I can quit out of there. And now I'm going to do cosine inverse of 0.6, hit enter. And we can do 3 decimal places. That's what we do in pre-calc, so 0.927. So basically what I want you to realize is that it's a positive angle, so from the positive x-axis here, it gives us this angle right here is 0.927, okay? So we know that one of our angles is 0.927 radians. But what about the other one, okay? So how can we find the second one? Okay, so I want you to realize this. We said all students take calculus. Cosine is positive in the first quadrant. Cosine's positive in the second quadrant. And this is 0 radians right here. Okay? It gave us cosine inverse of theta, cosine inverse of 0.6 is 0.927. So I know this angle is 0.927. It's not degrees, it's radians. And it's this angle right here. Okay? So now if I say, do you see an angle that's equivalent to that? I also know that this angle is 0.927, okay? Like, I just mean like if I took a protractor and measured how big this was, it's also 0.927, okay? So we need to find both of our answers. I'm going to change my color here. So my first angle is this angle from the positive x-axis counterclockwise until you reach that terminal side, which is the 0.927. My second angle is this angle that starts at the positive x-axis and goes counterclockwise until you hit the terminal side. That's the second answer. So I need to know, how do I get that second answer? Okay, that second answer, if you notice, it's a full rotation, which it's not degrees. So a lot of people are like, oh, 360 minus that. It's not in degrees, it's in radians. So to get my second answer for theta, I'm going to do 2 pi minus 0.927. Okay, ... because I'm going to hit second answer actually. So I'm going to do 2 pi, second, that one right there, minus, and then I need the 0.927. Some of you can go grab it, and if you can't grab it, you can just hit second answer and hit enter. So my second angle, theta, is 5.356. So my first answer is 0.927, and my second answer is 5.36. Now, is it always 2 pi minus that? No. Okay. So how do we get it? So it says to solve trigonometric equations using your calculator, first you're going to find theta using your calculator. Then you're going to think of where your 2 angles are, and then you're going to think about the easiest way to get those angles. Okay, so let's start with this one right here. So I don't necessarily do it in that exact order. You'll see how I do it. Use a calculator to solve each on the interval of 0 to 2 pi. Okay. So I need to solve this. So the first thing I do is I say, where are the two angles, which two quadrants? So I'm going to use all students take calculus. I know tangent's positive in the first quadrant and the third quadrant. So if you look at what your two angles are, I'm going to draw them and then I'm going to erase this so that it's not in the way at first. Here's my first angle, positive x-axis to the terminal side, and here's the second angle, positive x-axis to the terminal side. So I need to know what this is, and then once I know that, that's going to help me. So we're going to use tangent inverse to get that. Okay, let me get rid of that for now. So we're going to do tangent inverse of 12.804, and that is we're going to get an answer from that. Okay, well, not necessarily an answer, but we're going to get an angle measure from that. So tangent theta, or tangent inverse of 12.804. And we have 1.493. So we know that that is, oopsies, 1.493. Okay, so make sure you're not boxing that as an answer right away. You'll see why in the future. Okay, so it's positive. So what I'm going to do is I'm going to start at my positive x-axis, and I'm going to go in a positive direction, which is counterclockwise. That, whatever that angle is, that's the 1.493. So I'm going to label this 1.493. So now what you should also know from integrated is that vertical angles are congruent. So this angle right here is also 1.4. Well, I can't write it correctly. There we go, 1.493. So I know those two right there. Okay, that's all the information that I'm going to write for now, and now I'm going to get my two angles. Okay, so I'm going to change colors here so we can make sure we see them correctly. Theta is equal to positive x-axis until you hit the terminal side. That one's nice and easy, 1.493. My second angle, theta, I feel like I should switch colors here, so I'm going to do green instead. My second angle, theta, positive x-axis until you hit your terminal side. So how am I going to get that angle? Well, some people will say like, oh, it's 180. Remember, we're in radians. So it's pi, right, because that's pi. So it's pi plus 1.493 more. So I'm going to do pi plus that. So pi plus that last answer we just got there. So I'm just going to do second answer, hit enter. And my second answer is 4.634. There's my two answers that I'm going to box. Make sure you're showing how you got your second answer, because on your test, this would be worth 3 points, okay? 1 for this, and then 2 for this, because I need to know how you got that. Okay, let's look at the next one here. So first off, let's see where our answers are located. This is where cosecant's positive, and I say, cosecant, I don't work well with that. I mean, there's no cosecant button in my calculator. So what I'm going to do is I'm going to change it to its reciprocal. So I'm going to say the reciprocal of cosecant is sine. But then I have to take the reciprocal of 4, which is 1/4. So these have the same answers, so I'm just going to pretend it says that in the purple. So I want to know where sine is positive. So I'm going to draw my quadrants. All are positive here, students, so sine's positive here also. Okay, now I actually want to redraw this, because what you should realize is that this angle, I'm going to put a question mark for a second, and this angle have the same measure. I just don't know what that is right now. Okay, so now I'm going to use inverse, sine inverse that is, of 1/4 to get an angle measure. So I'm going to do sine inverse of 1 divided by 4, and I get 0.253. So now I'm going to label the angle that's 0.253. So I'm going to go from the positive x-axis. This is a positive number, so I'm going to go in a counterclockwise direction. That angle right there is 0.253. So I'm going to erase the little arrow because it might confuse me later. I'm going to label my other angle that's 0.253, which is this one right here. And now I'm going to find my two angle measures. Okay, so I'm going to go from the positive x-axis counterclockwise until I hit my first terminal side. So my first angle, which is not called theta, it's called x, is equal to 0.253. So there's one answer. Now I'm going to get my second angle, which is positive x-axis counterclockwise until I hit the terminal side. So I need that angle. Okay, so I need that angle. If it helps you to think about it in degrees first, you can. If I needed to get that angle in degrees, I could do 180 minus whatever this is, but it's not 180. This is pi. So I'm going to do x is pi minus 0.253. I'm going to do pi minus, and then I need that 2.526 whatever. So I can click on it like that, or you can hit second answer. So I have x is 2.889. And there's my second answer. Okay? So people are always looking for a rule, and they're like, wait, do you do pi plus or pi minus always? No, because we did 2 pi minus here. So you have to think about, right? Think about the easiest way to get the other value. All right, next one, tangent of theta equals -3. So I want to think about where my answers are first. So I'm going to do my unit circle. I want to know where tangent is negative. So everything's positive here, so not there. Sine's the only thing positive here. That means tangent's negative. So if you need to do, all students take calculus. Tangent's positive here and here, so not those. I want to know where it's negative. It's in the second and the fourth quadrant. So I have an angle here, and I have an angle here. Okay, so now I'm going to use inverse to help me get an angle measure. So I have tangent inverse of -3. And I'm going to write down what that is. Tangent inverse of -3. Hit enter, and I get -1.249. Okay, so first things I want you to notice is that this is not a final answer, the negative answer. Why? Because all of our answers are in between 0 and 2 pi. So what I'm going to do is I'm going to label which angles are positive 1.249 degrees. Okay, you'll see what I'm talking about in a second. All right, so if I said label the angle that is negative 1.249, I'd say, okay, I need to start at my x-axis, and then I need to go for negative angles counterclockwise. So this angle right here is negative 1.249. But instead of labeling it negative 1.249, I want you to label it positive, because I want it to be like the absolute value, like if you got a protractor out and measured it. So this angle is 1.249. Now I'm going to label the congruent angle. This vertical angle is congruent to it, so this is also 1.249. And now I'm going to get my two answers. Okay, so I'll go back to red again. Positive x-axis counterclockwise until you hit the terminal side. How can I get that angle? If you look right here, that would be 180 degrees or pi radians. So to get that angle, I have to do pi minus 1.249. So I'll do theta equals pi minus 1.249. Let's think about how to get my second answer really quickly before we put that in our calculator, because that itself is another task. Positive x-axis counterclockwise until I hit the terminal side. How do I get that angle? If you look, this is almost a full rotation, which is 2 pi, but I have to get rid of that 1.249. So my second angle answer is going to be theta is equal to 2 pi minus 1.249. So that's how I'm going to get my two answers. Okay, so I need to do pi minus 1.249. If you look at what's on my calculator, it's negative. I need it to be a positive so that I can subtract it, right? So to make this number positive, the first thing I'm going to do is hit times -1, okay? Now I can do pi minus that and 2 pi minus that, but I have to do two things. I have to do pi minus it and 2 pi minus it. So what I'm going to do is I'm going to store this as x, store as x, so that I can do that. Now, could I go up and down and that be faster? But not all calculators are allowed to do that, so that's why I'm doing it this way. All right, so I'm going to do pi minus, oops, I did plus, minus, and then I need that x value right there, 1.249. So my first answer, theta is 1.893. And then my second answer is from 2 pi minus that. So 2 pi minus x. Oops. And my second answer, theta, is 5.034. Okay? Now just to show you that x is what we said it is, if I hit just x right now, it's the 1.249. Okay, so that's the gist. We just did like one of the hardest possible ways I can do it. If you get a negative answer here, okay, your answer is never negative because it's in between 0 and 2 pi, so you're going to have to do something to find each answer. If it's a positive answer, then that is one of your answers. Okay. Next one I have cosine of theta is negative 0.4317. So first off, I want to know, where is cosine positive? This is too far to the left here. There we go. Sorry, where's cosine negative? All students take calculus. So cosine's positive in 1 and 4, so it's negative in 2 and 3. Also, you can see that this angle and this angle are the same measure. They're both the same distance from x. So once I find one, I find the other. Okay. So I'm ready to find that angle. I'm going to use inverse. So I'm going to do cosine inverse of negative 0.4317, and I'm going to see what that is. Cosine inverse of negative 0.4317. And I have positive 2.017. Okay, so let's first talk about what angle that is. It's the most common incorrect label angle. People will want to put it here, which is not correct. Okay, the angle your calculator gives you is from the positive x-axis, either clockwise or counterclockwise. So if you look here, it was positive x-axis clockwise, positive x-axis clockwise. This was positive x-axis counterclockwise. And the only reason it was counterclockwise was because it was negative. Okay, so this one is positive x-axis clockwise. They gave me that angle. So I'm going to label that angle 2.017. So this big obtuse angle is 2.017, and that means the other big obtuse angle is 2.017. So those two angles are 2.017. Now I'm going to come in and find theta. Okay, so positive x-axis counterclockwise until you hit your terminal side. So my first angle, theta, is 2.017. All right, now I'm ready for my second angle, positive x-axis, counterclockwise until you hit your terminal side. Now, some people will say, well, it's pi plus whatever this is. It's not labeled. Could we figure it out? Yes. Do I feel like doing it that way? Absolutely not. It's the longer way. So instead, what I notice is that this would be a full rotation, which is 2 pi, but I have to get rid of that angle that I just put in dashed. So to get that angle, I'm going to do 2 pi minus 2.017. So I have 2 pi minus that answer up there, which is just the second answer. So my other answer is 4.266. All right, let's try another one here. So this one's sine's not isolated. So to get sine isolated, I'm going to have to add 1 and divide by -5. So add 1 to both sides. I have sine of theta is equal to 3. Oops, -5 sine of theta is equal to 3, and then divide by -5. So I have sine of theta is equal to -3/5. Okay, so now I'm ready to do this problem here. I'm going to draw my x on my axis. I want to know where is sine negative. Sine's negative in the third and the fourth quadrant. So once again, this angle and this angle are the same. So I'll see what I can do to how that's going to help me. Okay, I'm going to put in my calculator sine inverse of -3/5 and see what I get. Sine inverse of -3 divided by 5. And I get -0.644. Once again, remember that is not one of your answers. It's going to help you get your answers, but it's not one of your answers. So now I want to find the angle that is -0.644. So positive x-axis, since it's negative clockwise, that's the angle that's -0.644. But I'm going to label it 0.644. I'm not going to put the negative in because we're going to use the absolute value of it to help us. Now I'm going to label the angle that's congruent to it. That's this angle. And now I'm going to say what my two angles are. So here's my positive x-axis, counterclockwise until I hit the first terminal side. That's my first angle. I have to say, okay, how do I get it? It's half of rotation, which is pi, plus 0.644 more. I'll do the other one while I'm here. How do I get that other angle? Positive x-axis until I hit my terminal side. So that's almost a full rotation, which is 2 pi, but I have to subtract that 0.644. So remember, I have to use it twice, so I want to store it as x. Positive 0.644, that is. So I need to store this as x, but I need to be positive. So first I'll hit times -1 to make it positive. And now I'll hit store as x. It'll save over my last stored value. And now I'm going to do pi plus x. That'll be my first answer, which theta is 3.785. And now I will get my second answer by doing 2 pi minus x. So my second answer is 5.6. I was going to do 639, but if you look at it, it's 396, so that's 40. All right, one last one here, and then I have 2 for you to try. So secant needs to be isolated, so add 9 divided by 3. So I have 3 secant of x equals 15. Divide by 3, secant of x is equal to 5. There's not a secant inverse button on my calculator, so I'm going to change it to its reciprocal, which is cosine. But then I have to take the reciprocal of 5, which is 1/5. So now I want to know, where is cosine positive? First and fourth quadrant. I'm going to use cosine inverse of 1/5 to get an angle measure. Cosine inverse of 1 divided by 5. That is 1.369. Now I'm going to label the angle that is 1.369. This is a positive angle, so I'm going to start at my x-axis, go a positive direction. That angle is 1.369. Remember, I delete that then, 1.369. I'm going to mark the other angle that's 1.369. That's this angle right here that's congruent to it. And now I'm going to find my two angles. Start at the positive x-axis, counterclockwise until I hit that. So one of my answers is 1.369. My second answer, positive x-axis, counterclockwise until I hit the angle side. Almost a full rotation, right? But I have to get rid of 1.369. So that is 2 pi minus, oops, that doesn't look like 2 pi. Clear? 2 pi minus second answer. So theta is 4.914. So there's 2 answers there. Okay, why don't you pause the video and try the next 2 on your own, and then you can come back and see how you did. All right, if you got theta is 3.481 and theta is 5.943 for 7, and then for 8, x is 1.738 and x is 4.545, you did both correct, and you can move on to the quick review. If you didn't get those, let's see where you made a mistake. My calculator does not have a cosecant button, so I'm going to change it to its reciprocal, which is sine, and then I need the reciprocal of -3, which is -1/3. Where is sine negative? The third and fourth quadrant. Ooh, I forgot theta there. So now I'm going to do sine inverse of -1/3 to get an angle measure. Sine inverse of -1/3 is -0.340. Remember, that's not an answer. It tells me, I know because it's negative it's not, so I know that I'm going to have to do work to get both my other ones. Let's label the angle that's -0.340. Negative angle, so positive x-axis in a negative direction. That's my angle. And then remember, once I know my angle, I'm going to label it positive 0.340. I want the angle that's congruent to it. That's this angle right here, 0.340. Now I can find my two angles. So let's start off with how. Positive x-axis, counterclockwise. So that is pi plus 0.340. My other angle, positive x-axis, counterclockwise, and that's almost a full rotation, which is 2 pi, but I have to get rid of that 0.340. All right, so I'm going to find the second angle first since I'm still in blue marker here. First off, I need to make sure that it's positive 0.340 so that I can add and subtract it and use it twice. So I'm going to first multiply it by -1. Now it's positive, and now I'm going to store it as x. Now I can do 2 pi minus that. Theta equals 5.943 is my bigger angle. And now for the smaller angle, I'm going to do pi plus x. And I have theta equals 3.481. And that's how I got those two answers. This one here, to get cosine by itself, I have to subtract 2 and then divide by 6. Where is cosine negative? Second quadrant and the third quadrant. Okay, so now I'm going to use cosine inverse to help me find an angle measure. Notice I'm not saying to find the answer, to find an angle measure. That might not necessarily be my answer. Cosine inverse of -1/6 is 1.738. So now I'm going to label the angle that's 1.738. This is a positive angle. So positive x-axis, counterclockwise. That's the angle that's 1.738. So I'm going to put 1.738 here. Now I'm going to label the other angle that's 1.738. So that is the other obtuse angle. So not this angle, not this angle, the other obtuse angle. So this right here is 1.738. And now I'm going to find my answers. Positive x-axis, counterclockwise until you hit your first terminal side. So you can see that your first angle, x, is 1.738. Now let's get our second angle, positive x-axis, counterclockwise until I hit the side. So I need that angle. I don't know what this is right there. I could find it, but I don't know what that is. I don't know what that is, so that's not how we're doing this. So I say, oh, look, this would be a full rotation, but I need to get rid of that 1.738. So my other answer I get by doing 2 pi minus 1.738. So I'm going to do 2 pi minus second answer. And I get my second answer is 4.545. Okay, that's it for the calculator usage. So I'm going to get rid of that so I have, more room. This is review. So this is same. This is if you struggled with what we ended with on the last set of notes. Okay. Solve each without a calculator. Use the interval 0 to 2 pi again. Okay. So first off, I asked myself how many terms there are. There's 2 terms, a tangent and a sine. So remember when I do this, I'm going to get everything on one side of the equation. I'm going to attempt to factor it. Okay. I'm going to get everything on one side and attempt to factor it. So if I do that, I have tangent of theta minus 2 sine of theta, and I notice there's no GCF, and it's not 3 terms, so I can't use my diamond to help. So that's not how I'm starting this. So instead I say, okay, well now I need to check to see if I can replace anything. I can replace tangent, so that's what I'm going to do. I'm going to change tangent to sine over cosine. Then I'll make this a fraction, and then I realize I have a proportion, so I'm going to cross multiply. So I have sine. Sine times 1 is sine, and then 2 sine times cosine is 2 sine cosine. So multiply. I have 2 sine cosine, cross multiply that is, equals 1 times sine, which is sine. It doesn't matter which one you do first. I could have sine equals. All right, now I'm going to get everything on one side and then try to factor it. So I'm going to subtract sine of theta from both sides. So now I have 2 sine of theta cosine of theta minus sine of theta. Now I can see that it is factorable. It has a GCF. So I'm going to factor out the GCF, which is sine of theta. And now I can set each factor equal to 0 and solve those. So I have sine of theta equals 0 and 2 cosine of theta minus 1 equals 0. The First equation is solved for sine of theta. The second equation is not solved for cosine of theta. So I need to solve that for cosine of theta by adding 1 and dividing by 2. And now I can solve these two equations. Let me highlight them. I can solve these two equations. They're not my answers. I still need to find theta, the variable. All right, so I need to know where sine is 0, where the y value is 0. So unit circle for help. Where's the y value 0? So here, this is the point 1, 0. The y value is 0. That's 0 radians. Here's the point negative 1, 0. The y value is 0. That's pi radians. So far, I have two answers, 0 and pi. Let's see if I get any more answers from this. I need to know where cosine's positive. First quadrant, fourth quadrant. Cosine is your x value. Those are my pi over 3 angles. In my first quadrant, that's pi over 3. In my second quadrant, that's 5 pi over 3. So 0, pi, pi over 3, 5 pi over 3. Okay, the next one. So same idea, there's two different types of trig functions here. If I subtract cosine from both sides, I can't factor it. And there's nothing that I want to replace because I like to leave sines and cosines. So remember, if that's the case, you have to think about it. Where is sine and cosine the same? What ordered pair has the same x value and y value? Root 2 over 2, root 2 over 2. But also realize in the third quadrant right here where it's negative root 2 over 2, negative root 2 over 2, that's also true. So we have two answers. That's our pi over 4 angles. The first one's in the first quadrant, so pi over 4. The second one's in our third quadrant, so 5 pi over 4. Okay, you can pause the video and try the last two on your own. All right, number 9, you should have gotten 3 pi over 4 and 7 pi over 4, 10 pi over 2 and 3 pi over 2. If you didn't get those answers, here's how you get them. This one here, it's two terms. I can't factor it. I don't want to replace anything, so I'm going to balance it and get one on each side and then think about it. This is saying where are sine and cosine the opposite of each other. So same number, just opposites. That's in your second and fourth quadrant, where it's negative root 2 over 2, positive root 2 over 2, and root 2 over 2, negative root 2 over 2. So that are my pi over 4 reference angle, but in the second quadrant, that's 3 pi over 4, and in the third quadrant, that's 7 pi over 4. This one here, if I try to get everything on one side, it's not factorable, so I say, okay, let me first try to replace. I can replace cosecant. So now I have sine of theta over 1 equals 1 over sine of theta. It's a proportion that I can cross multiply. Sine times sine is sine squared. 1 times 1 is 1. So this is a squared function, and I can solve by square rooting. So I'm going to square root. Remember, whenever you solve an equation by square rooting, you have to account for the positive and negative answer. So now I have sine of theta is equal to positive 1 and negative 1. So I want to know where sine is 1 and also where it's negative 1. That's the y value. So here my y value is positive 1, so one answer is pi over 2. Here, sine is negative 1. So my other answer is 3 pi over 2. All right, that's it for today's notes. You can go ahead and get